Hello, everyone. I will introduce myself shortly. I'm Hossein. Just landed today morning in London, first time in London. I'm based in Germany. And when I left home today in the morning, it was sunny. I mean, usually I look the weather between Hamburg and London. I say, which city should I live in? They are same. But today was sunny in London. I didn't feel homesick, to be honest. Platform engineer. I had many hats a few years going back. DevOps engineer, platform engineer, system administrator, so you name it. Today I'm going to talk about what we have been last few years building with my team. Not only us, all the community. We have been building internal dev platforms based on platform engineering practices. And what I can see from our perspective from the project we are doing, some project went really well. The customers are happy, successful. It really boosted, their software delivery, software development processes. They made both developers and platform teams happy. From the other perspective, some people got not really happy because they had to deal with some static portals, unfortunately. We're going to take a look how we can not bypass portals, how we can use agentic AI to open a new door to internal dev platforms. And on that way, we're going to use CNOE, one of the community projects. Some folks from AWS started developing these projects a few years ago, and of course, the famous MCP. We're going to talk about the current status of internal dev platforms, how agentic AI MCP is changing the ecosystem, and what are the baselines, what are the definitions of AI native platforms. On the way, I'm going to introduce a new reference architecture based on CNOE and one of the recent projects called KP, and I'm going to show you a short demo how it works. Internal dev platforms. Quick flashback. Almost 10 years ago, I got a call, middle of the night. Of course, I was on duty. I had a call from one of my colleagues, 2:00 a.m. He's calling me. He's one of our on-prem infrastructure ES6 admins. He's calling me and saying, this new platform you guys built and pushed into production is causing lots of noise and lots of pressure on our ES6 machines. And your nodes are utilizing almost 100% of CPUs, and one of ES6 machines is going to explode. We don't know when. So I'm just opening my laptop. I'm trying to understand what is the problem. So because we haven't seen this kind of behavior or phenomenon back in the lower stages. So I'm quite puzzled. I'm confused. So I'm just going from top down. I'm just logging into our Kubernetes cluster in the prod. And then I'm looking at the cluster. I mean, the applications are fine. I cannot see any pressure at the application side. I'm going deeper. I'm going into the nodes. I'm seeing the pressure there. And I'm not sure where is the problem is coming from. So if you are familiar, with the on-prem infrastructure based on, for example, VMware, you have different layer of abstractions. So we put one layer on top based on Kubernetes, a new abstraction. So we made the life of everyone more complex. So Kubernetes is fine. So I'm just drilling down, going to the nodes. I'm going down to the VMware side. I'm looking at the reservation we have defined for production. I'm like, is it again, hyper-threading problem? Because we have deactivated this for production. So long story short, I found the problem. It was the VMware back in the day storage plugin we used to provision persistent volumes was causing the headache. So it was really deep issue, cost me 3 hours to find out. But internal dev platforms help developers, help platform engineers, but still people who are on duty calls, like sysadmins, like SRE engineers, are not benefited. So platform engineering came with the promise of, okay, so we're gonna bundle, we're gonna glue bunch of toolings, a bunch of platforms in a streamlined way, in a standardized way, that they can collaborate with each other on top of all these complexities, infrastructure, platform, orchestration. We're going to create a new layer to abstract all the complexity. And yeah, we're going to put we're going to template everything. We're going to standardize all the solutions so that a developer can just come and get let's say, a normal service. So yeah, and the main focus was that how we can improve self-service, how we can improve the dev journey. So yeah, the output was glorious for devs. I mean, yeah, we can see by looking at the KPIs, the software release process really increased in the last few years. So this is one of the reference architectures. If you look at also at your companies, organizations, you're going to see something similar. We have different capability planes. This, for example, is coming from one of the community's publishments. So yeah, we have traditional control planes, we have compute plane, we have observability, we have secret management, etc. But as you can see, if we move to the developer, control plane, we had IDEs. Everyone is using VS Code these days. I mean, not because of the cool agentic plugins, and the portals, like more specifically Backstage. So, to be honest, the part of the practices went quite well, like putting all the capabilities together, writing templates, automation, standardizing the solutions, and ownership. Of course, someone needs to own the platform. But where it went wrong was just focusing on this one thin layer on top of that, which is portals. I don't want to put my finger on Backstage, but a few days ago I was talking to one of the chief architecture of one of the big telco companies of Germany, and he was telling me, so we are thinking about introducing Backstage in our organization, and we have around 25 development teams, and we are thinking about deploying Backstage per team. I'm like, okay, good luck. If you can handle Backstage, because Backstage is not really a small piece of software, it's really complex. If you look at the philosophy behind Backstage from Spotify, you will understand what I'm saying. There is 5 people who are managing the central instance of Backstage at Spotify, but there are 120 teams are developing continuously this application. Yeah, that's what we should always keep in mind. So yeah, Portal was the main focus. As I said, it works for some people, but for example, for someone like me back in the day, SRE engineer or system administrator, it doesn't really help me with firefighting, to be honest. So yeah, UI grows. We can put some shiny catalog, some new tabs, some new dashboards. Okay, yeah, let's integrate Grafana, let's integrate Dynatrace, let's integrate our CI/CD, GitHub actions, whatever, into Portal. But honestly, the capabilities, they start, the integration of capabilities start getting slower. So this is the pattern we see in lots of our projects. So yeah, because yeah, some people are honestly mistaking discovery with delivery. So yeah, the more you discover what you have built internally into portals, of course, you're gonna make it more present. But the question is that, are you treating your portal as a glorified bookmark manager? Okay, here is tab 2, 3, 4. But that doesn't mean delivery. Delivery means that how I can enable my developers, the end user to access the services on demand. So looking at the few talks that I saw today, so agentic AI and MCP are playing a part, how we can change, this picture. So the MCP, the Model Context Protocol, is a term that I think we have heard in the last 2 years a lot. I mean, all the platform engineering talks I attended in KubeCon back in Amsterdam, this was everywhere. So everyone was talking about MCPs. And some people, they were saying MCP is dead. Yeah, I can understand there's a huge discussion in the community about MCP because, yeah, MCP is eating lots of tokens. The token consumption is going to the sky. Second is that MCP is not really considering, authentication, authorization. Yeah, these flows were there, but I think this is the normal life cycle of any piece of code. So of course it will iterate, it will improve. So why MCP? So if we go back before MCP, the first time I could connect my chatbot with LLM and say, okay, hey, here's my Kubernetes cluster. Can you just tell me what's going on with one of my pods? It's in the crash loop back off. I had no idea what's happening, to be honest. So then I realized, okay, so some folks, they wrote really customized API integration for specific LLMs. So it differs from provider to provider. And imagine if the provider changes the API or the end platform changes the API. So this SYN layer should be, again, changed. So that's why MCP emerged. So MCP is this universal adapter, help us to communicate in the same way to end platforms, so end toolings, APIs in a similar way. So it just exposes the state of the API or the platform called resources, and also enables us to execute the model invoke actions by MCP. So, so let's look at how it works these days. So as I said, we are using our MCP clients. I don't walk out of my terminal per day. I'm not really a UI person, so this is how my daily life looks like. So I'm communicating definitely with some customer Kubernetes cluster using MCP server. So the same goes with the observability platforms. Same for Grafana, and just in case, if I need to fetch some information from GitHub, goes the same. But to be honest, MCP is not about boundary. As I said, it's this universal adapter. It allows us to communicate in the same way with different endpoints. It doesn't come with any boundary. So that's where the door gets open. So the MCP fetches, the agent fetches the concept, the context. So it evaluates the options and then asks for permission to execute some actions. So this is what we should expect, from the agents using MCP. So, so which resources are accessible? So if the changes are gatekept, or should I block accessing specific credentials? So it's not covered here, to be honest. So let's look at the terminology of AI native platforms. So going back to the agentic AI, so as I said, back in the day, so technically I just could talk to my chatbot using the agent to perform different actions on different platforms without knowing what are the consequences, to be honest, at the beginning. So by giving this, some colleagues today, they call it don't give the Ferrari keys to kids. So this is exactly what happens. Don't give the root key or root API token to agents. So maybe 90% of cases, nothing gonna happen, but one case can go wrong and it gonna cost you a lot. So I was 1 month away before KubeCon. I literally just came back from a vacation to KubeCon. I heard 2 stories. One of the GitHub, I think agents, or one of the GitHub, the plugins had enough privilege to delete whole 3V repo. So if you're familiar with 3V repo, so it's one of the well-known community solutions to scan for artifacts vulnerability. So imagine the agent got so much privilege, could delete whole repo. So next day, the maintainers are coming, it's gone. So what happened? We don't know. Yeah, they reverted the project. I mean, they could bring back everything. Of course, they had the local instance, but if you talk about 3V, people are like, no, let's look at other solutions, to be honest. And the other one was that I think in one of the the banking customers, the agent deleted whole database in the production. Yeah, that might go as well wrong. So short story, please don't give direct access. So how should we do it? So I think this is the repetitive story. Other speakers, they talked about it. So it's about how we can put boundaries, how we can put guardrails. I mean, platform engineers are well familiar, with putting boundaries, enforcing policies, using Kyverno, OPA, all these gatekeeping solutions. It's the same here. We should make contracts, with agents. We should put guardrails. We should gatekeep the actions before hitting the APIs. It doesn't matter. It's cloud platform, it's Kubernetes, or whatever. So let's look at how the relationship flow looks like. So as a developer, so as soon as I just write my prompt, so the agent will start evaluate the options. So it will prompt some proposals, and then of course it will try to execute some actions. That's what in their nature. So the thing is that's where the platform engineering team comes to this loop. So that's where they should. I don't say they should write opinionated controller by themselves, but honestly, right now in the community, I don't see any controller natively can handle this kind of I would say agent gatekeeping. So classical Kyverno OPA. So they evaluate, the request you are sending, based on the policy they have in the runtime. But we know these systems, they have non-deterministic, nature. So it can mutate. So and then of course we have this GitOps loop in all over of our workflows. So we have to use it. So it means that when there's a change should be supposed to happen in our whole platform or our setup, it should go through the same loop. It should go through GitOps. So if there's a change, it should be proposed as a PR. It will go through the Git repo. It should be reviewed. And Argo CD or Flux or other toolings you're using should be able to synchronize it, with your platform. Yeah. So going back to example I gave at the beginning, this 2 o'clock, 2 a.m. SRE engineer call. So it doesn't matter, it's a drift, it's a signal. I got a call from my colleague. So yeah, we have a problem, something is going wrong. There's a CPU throttle, there's a OEM killer in the platform. Can you take a look? So of course, I will open my laptop, I will jump to my terminal, and I will talk to one of my agents, and I will ask for help. So of course, the agent's gonna start reasoning, evaluating options, and we'll come back with some proposal. Yes, I found the reason. The reason is that, I don't know, your memory request limit is quite low. So that's why you are hitting OEM killer. So, and so that's where that, the policies or, the guardrails that the platform team has set should be evaluated. This should be checked against the rules. For example, if the platform team has set quota for namespace, so it should be evaluated against that namespace. So is it possible that we can propose this change or not? Or we need some other changes, maybe also increase the quota. So and the final review will be done by peers. So someone will review, human peer. Someone will review the change, and the same GitOps execution loop that we talked about. And after it's verified, it will be reconciled by GitOps back into our platform. So who will own this new concept? Of course, platform engineering team. So Good or bad, they used to be also responsible for maintaining platform, developing platform. I mean, the portal itself. But now they can own, these contracts that I mentioned. The audit trails. I mean, some of them are not something new. We have already these practices, in our current, platform engineering ecosystem. So, and yeah, what is really important is that they should be maintained, and they should be continuously checked by the same teams. So we talked about all theory, how the govern action loops they look like, how the boundary looks like, how we can keep the agentic AI MCPs, under control. So what are the practices in the community, in the cloud native community? So as I mentioned, the CNOE is one of the projects. Some folks at AWS, they started projects a few years ago. So if you look at the CNCF landscape, I think, you will be like, okay, where should I start? Which tool should I pick? So I don't want to put it here because it's horrifying, to be honest. It got even more complex. So these folks, they came with the idea, okay, there are some tools we can say, okay, they are not de facto, but they're best practice, like Argo CD, like Keycloak, like some bunch of tools. We can put them together, and we can make a blueprint how a mature and well-built platform can look like. So this is what they came across. Lots of tools from your daily work. So for secret management, for let's say versioning, for example, Crossplane for managing infrastructure as code via Kubernetes, Terraform. So yeah, they're the tools that they're well known, I think, in our ecosystem. So last year they started a new project called KP, Community AI Platform Engineering. So the focus is that, and the assumption is that your base platform is built by something like CNOE. So you have all the capability planes. You have observability, you have control plane, you have workload, etc. You have all them in place. So, and to help people like me, like SRE engineer, waking up at night, they propose a multi-agentic AI system. So what does it do? So technically, you can create your own agent by connecting different MCP servers to KP. And by definition of the agent, you can just pick up the skills you need. So I will show in the demo one of them. So I can pick up, say, okay, this is my SRE engineer agent. So for example, what I need to be able to communicate with Prometheus, I need to be able to communicate with Grafana because I need to get the logs from Loki. For example, some other tools like NetUtils because I want to measure the latency, for example, or some tracing tools. So yeah, it gives you full flexibility. You can connect it to your knowledge systems, your rack systems. So yeah, it also can help you to get more information from your organizations. And of course, you don't want to be interrupted, middle of investigation, I don't know, a network packet loss, and you will lose all the, your context. So it will be stored in a database. And I think the most important factor is that how we can ensure that who is behind the agent is someone who is authenticated. It's me, SRE engineer, and then it should be checked what is the scope of the access of the SRE engineer. So that's how KP is keeping the access in control. So let's look at the architecture. So on top of the stack, so again, it doesn't matter. So it's KP Portal. I will show you Portal. I'm running away from Portal, but I will show you Portal here. You can use KP CLI API, up to you. So they are using an agentic gateway to expose, the MCP server and how they are communicating, with external authentication authorization the platforms. So in the core of the platform is this supervisor agent, which connects directly to your LLM provider, and also is able to delegate your int. I mean, let's say I'm a developer or I'm the end user. I have an intent, so it able to delegate that intent to a right agent, and at the end to the correct MCP server. So as I mentioned, the authentication is, you can see it's done by Keycloak, or authorization is done by OpenFGA. Interesting that they also integrated this tool, because it's getting really popular in the community. The cross-session shared context is stored in Redis, that we can keep the memory, because my experience shows that the incidents are iterating. So most probably the same incident gonna happen, and it's important that we have memory of that. That can help agent to identify it and propose a solution quicker. So. It's honestly, it's not that complex as it looks like. So as I said, when there's a prompt, so the supervisor agent is able to delegate, those requests to respective agents. And if an agent is not able to handle the request, it will be sent to another agent. So that's why we have agent-to-agent concept here, and at the end it will hit the MCP that can satisfy the intent. So imagine that what I showed you at the beginning. So we had at the developer control plane, we had IDEs, VS Code, popular everywhere. So what was missing, I mean, at least for me, was this agentic part. So now we can also integrate the agentic part into internal developer platform. There are lots of skepticism, as we saw today. It might go wrong, but I think till we don't fail, we won't learn. So we will, I don't know, we might delete another production database, hopefully not. But that's how we learn, to be honest. So that's the pain we will take. So, and as you can see, the KP is extending this layer. So KP is seating exactly in front of the agentic part and is able to handle the request and connect it to the right platforms. So I will quickly go to the demo. About the demo, it's exactly what happened to me, but something easier. So there's a call, middle of the night. There's an application, classical Go application, is going through CPU throttle. And as a good platform engineer, we have written all the good alerting rules. And Prometheus is firing one of them, and that alert manager is directly sending it to the KP supervisor agent. So, and then what happens? The supervisor agent is gonna reason it with the LLM, and will contact the respective MCP server, and that MCP server, which is, I think, in this case is Prometheus MCP, will come up with the root cause. And also, I will show that I will ask for a solution. It will also give us a solution. And then finally, it will go through the Git. It's open source Git management system. So the MCP will also create the final pull request. The human verifier will accept the pull request. Argo CD will see the drift and will sync the Git repo status with the Kubernetes. So, I hope you can see my screen. So this is the KP UI. So I will just shortly show you how does it look like. So these are the MCP servers I have connected. Yeah, there we go. So these are the MCP servers that so far are connected, Argo CD, Git, yeah, I'm not really using knowledge base, but I use the ones that I need for this demo. And I have defined my own agent. So which MCP servers I want to use, sorry, not that one. I want to see, yeah, there we go, tools, yeah. So I have selected which skills I need, so all are pre-selected. So I will quickly simulate the situation with CPU throttle. I hope the terminal is also big enough. So this is just gonna tell Alert Manager to send the webhook via webhook. Yeah, there we go. So it just hit the KP server, so we can see there is a high CPU throttling. I don't want to go to the detail of the alert. So the same we can see at Prometheus side. So the alert is firing, so it's active. So I will show you what's happening with the application itself. So if I just top pot it, so you can see that so the limit of the CPU limit of the application is 200 milli-CPU. So so it's already hitting, you know, the limit, so it's throttling technically. So technically what I was going to show you gonna happen here. Yeah. So yeah, this is I've just wrote a script that I can verify that the demo is so far ready. So this shows the KP control plane in the KP namespace. And the production application, which is throttling. Yeah, exactly. So yeah, I will just watch the application, because at the end I should be able to verify that Argo CD is going to patch the application, and there will be new pods running. So yeah, I triggered. There we go. So no changes there. Yeah, the CPU alert is fired. Same there. No changes are expected here. Yeah, technically the same rundown, nothing new. The only issue I came across, they are not supporting any. They are compatible with LiteLLM, but it was a bit cumbersome. To let you know that we are, internally we are using LiteLLM. We are not exposing, the LLMs directly to, to our internal users. So we are using, a gateway front of the public LLMs. So yeah, just what I did, I just put quite well guarded prompt. To be honest, I saw how it can easily go wrong. So I just told the agent, okay, so it seems that there's a CPU throttle in the payment service in production. So use the Prometheus MCP and identify the issue. It will now, will show the reason and the root cause as expected. Yeah, I mean, it's sometimes explains more than expected. Also able to show me how the workflow of Argo CD looks like. So the next one is yeah. I deliberately ask, look at also the Argo CD, look at what is the best way to update the application, considering using GitOps. So far it's healthy, but we know that it's hitting the CPU limit. So the final prompt is that just tell me exactly what I need to fix, and for that, give me a PR. So the PR is already opened, so I will switch to Git interface. Inside the PRs, I should be able to see the CPU limit bump from 200 to 500. And that's it. As a good reviewer, I will read all the comments. Not just like going through and then, yeah, of course, look at what has changed. Not by mistake, accidentally something is deleted. And yeah, please also delete, your feature branches. Feature, patch, fix, whatever. So yeah, Argo CD is going to detect it and should be able. Already is spinning up new pods. So it's the rolling update mechanism. So it will wait till all the pods are LCM one by one. It will take them down. Yeah. So. I think that's it. Just to recap what we saw. So. This new design, the AI native IDPs using agentic AI and MCPs, treated as a standard platform, not a magic that we saw with portals. That portals will come and will solve everything. No, that's not a silver bullet. We need to think about how we can put the boundaries, contracts, guardrails to keep the agents, in the governed action loop. Think about people like me who are doing day two jobs. So yeah, we are also involved. Use MCP to get as much as possible information about the platforms that you are interacting, but the changes you're gonna make. If it's possible, use GitOps or Git, as single source of truth. If it's Terraform or other automation systems, use it as single source of truth and human in the loop. As I said, use AI to automate as much as possible. I think that's the best case for AI, is to automate the things that we don't like to automate. They're so boring. So that's what I also daily do. I try to automate the things that I can do with AI. but at the end, I think we are the ones that who should verify the changes or accept the changes that they are proposing.